the degree, whatever the highest degree is when it's the standard form affects your end behavior. So, I mean, I'm just sketching a couple of graphs. End behavior is talking about which way is it going on the left. Your graph is going down, right? Which way is it going on the right? It's up. And that's how we describe end behavior. You do the left side first and the right side second. But I'll tell you how to determine that here in just a second. All right, so if you will, take just a minute. This is describing the end behavior. It's based off of the degree and whether the degree is even or odd. Okay, we all know even and odd numbers, hopefully. And it is also determined by the leading coefficient of your highest degree term. I'm going to give you a way, hopefully that helps you remember it a little bit easier once you have a chance to write that down. Make it a little bit bigger for you. Try to. Whoa, too big. There we go. So two things happen. If it is an even degree, we're going to think about the graph of y equals x squared. That is a quadratic graph. And the reason we're thinking about that is because we know what those look like. We've dealt with those quite often. If your leading coefficient is greater than 0, then that would be a positive parabola. How does a positive parabola look? It looks like a unit, right? So what I'm going to do is just draw a little bit of a picture next to each one of these, and you probably want to draw it too, so that you can just kind of look back at it when we're talking about our end behaviors. So if it is an even degree, okay, the highest degree term, if your exponent on that degree is even, then it's going to be somewhat similar. The end behavior will be at least of a parabola. If my leading coefficient is greater than 0, meaning a positive, that means my parabola is going to be opening up. And we would describe that as left side is up. The right side is also up. Okay. Now, if it's an x to the fourth, your graph isn't going to look exactly the same as an x squared, but the end behavior will be the same. When you add more x or higher exponents, you get more curves in your graph. Turning points, as we call them. But the end behavior is still mimicking what a parabola looks like. If your leading coefficient of that highest degree term is negative, then it's going to be like a parabola that goes down, which means your left side would be down, and your right side would also be down. Okay, even if your leading degree is a 10th power, it's still going to mimic the end behavior of a parabola. So we're familiar with those graphs. We know what they look like. So it's easiest to just think about those if our highest degree term is even. Now, if our highest degree term is odd, we can just think about a linear graph, okay, a line, because we know what slopes look like. We know what positive slopes look like. We know what negative slopes look like. So if my leading degree term is an odd exponent, then two things are going to happen. If your leading coefficient is positive, it's going to look like a positive line. If you think about what that looks like, if I can, get this thing to right, sorry. A positive line looks like that, correct? Positive slope line looks like you're going upstairs. So what would my left side be doing, going down or up? Look at your picture. Your left side is going down, and your right side is going up. And if that leading degree or the degree of your highest term is odd and your leading coefficient is negative, it would look like a line with a negative slope, which looks like that. Which means my left side would be going which direction? Up. And then my right side would be going down. Now again, you can't determine this until your polynomial is written in standard form so that your highest degree term is written first. Then you can look at the number in front of that. If that number is even, whether it's even or odd, an even coefficient in front of an even degree would be an up and an up. If it is an even, positive, I think I said that whole wrong. If the number in front of your even degree is positive, then it would be going up and up. If the number in front of it is negative, you would be going down and down. And then if the leading term is odd and the coefficient in front of it is positive, think about positive slopes. Just always just kind of draw myself a line, or at least think of it in my head so I can decide which direction it's going on the left and which one is going on the right. So when it's asking for end behavior, that's all we're doing. What is the left side doing? What is the right side doing? We don't have to do anything else. Okay. Now I'm just going to show you a few different graphs. You do not have to copy these down, but to see what some of the graphs that we don't do, the fourth powers and things like that, the cubics that we don't do a lot, so that you can kind of see those. You do not need to write them down. I just want you to take a look. Okay, so I'm going to start here. I'm just going to ask you a couple of questions. What is the highest degree term in that first picture? It's an x to the what? Fourth, right? So that would be an even degree. So it's either going to be up and up or down and down. And we base the rest of that off of the number in front. Is that number positive or negative? Positive. So it would be going like a parabola up and up. Even though the graph looks different than a parabola, if you'll notice, your end behaviors are both up there. Does that make sense? And then on the second picture, what is your leading degree? 2. Okay, so that's an even one again, but then we're going to look at the number in front of it. The number in front of it this time is negative, so it's going to be like an upside down parabola, which it actually is pictured, and the left side goes down, and so does the right side. Okay, so just kind of looking at a couple of different graphs. Then the other two are my odd ones. Those are cubics. We don't do cubics a lot in here, especially graphing them. However, if we look at our degree, the highest degree is 3. And then we want to look at the number in front of that. Is that number positive or negative? Positive. So it would be, if you think about what I just told you on the previous slide, it would be like a positive slope where your left side is going down and your right side is going up, just like it did on my line that I drew up there. Does that make a little bit of sense? And then this is an odd exponent, so that your highest degree is odd. So that is going to be like oops, not going too far. And then the number in front of it is negative, so that's going to be like a negative slope, which looks like that. Okay, where your left side, we do that first, goes up, just like that one, and your right side goes down, just like that. Make a little bit of sense? Okay. Again, before you determine it, you've got to make sure, first of all, that you write it in standard form, putting your highest degree term first. Sometimes it will already be in standard form. Sometimes you'll need to change it around just a little bit. Is everybody ready? All right. So we are going to be looking at each one of these. We're going to just determine the end behavior. What is it doing on the left side? What is it doing on the right side? That's all we have to do here. We just need to figure out what is the highest degree term. Make sure you look at it in standard form. Or even if you don't turn it to standard form, you need to look individually at each term and figure out which one is the highest degree. That's the one with the highest exponent. Okay, so the first line is y equals 4x to the third minus 3x. So what is the highest degree on that one? It is a 3. Okay. So that's odd. So it's going to be like a line. We just have to determine if that line is going to have a positive slope or a negative slope. What is the number in front of that x to the third? Is it positive or negative? It's positive. So think about a positive slope line. What would my left side be doing? Going down. And then my right side would be going up. Does that make sense? Again, I like to think about a line and a parabola because those are the two graphs that we use a lot. Even if it is not that degree, it's something other than that or similar to that. So go ahead and try 2, 3, and 4. Look at your highest degree term. That determines whether it's even or odd. So if it's an even number, it's like a parabola. If it's an odd number, it's like a line. Then look at the coefficient in front of that. If that is positive, then think about a positive parabola going up and up. If it's negative, be down and down. Or if it's an odd exponent, then think about your positive slope lines and your negative slope lines. And on our quiz, when we do the end behavior, just remember we always do the left side first. You'll notice I'll put a little L and a little R to help me remember left and right. If you get it backwards, that's the wrong end behavior, okay? So the left side has to be written first. We read from left to right, so we're going to look at the graphs from left to right. So the end behavior is listed left side first, right side second. Now, my number 2 is y equals a negative 2x to the 4th plus 8x to the 3rd minus 8x squared plus 2. Is that already in standard form? It is. So my first term is the one that I'm focused on. This right here. Is the exponent on that even or odd? Even. And then the number in front of it, is it positive or negative? Negative. So that is going to be, since it is even and it is negative, that's going to be like a parabola that goes upside down. So the end behavior on my left side goes down. And the end behavior on my right side also goes down. Does that make a little bit of sense? Somewhat, maybe. Number 3, I've got y equals 1/2 x to the 3rd. Is that in standard form? Yeah, it's only one term. Okay, so we're focused on that. Is my degree even or odd? It's odd, so that means it's going to look like a line. We just have to determine if it's a positive sloped line or a negative sloped line. Is the number in front of it positive or negative? Positive. So we're going to think about a positive sloped line. So my end behavior on the left goes down, and on the right it goes up. Anybody have any questions? Number 4, I've got y equals 3x minus x to the 3rd. Is that in standard form? No. Okay, so we can either rewrite it or we can focus on the highest degree term. It's probably safer if we rewrite it. What goes first here? The negative x to the 3rd, and then that would be a plus 3x. If you don't rewrite it, that's not saying you're doing it wrong. We just need to make sure we focus on the highest degree term, which in this case is this first one, the negative x to the 3rd. Is my exponent even or odd? Odd, okay. And then we need to look at the number in front of it. Is that positive or negative? Negative. So it's going to be like a negative sloped line, which looks like this. So on the left side, my graph is going up. And then on the right side, it is going down. Anybody have any questions? That's it. That's all you got to do.